This is our last question that I will discuss through this video. I believe you can answer and understand the questions number 7 by yourself. But once again, if you need me to explain in details, please ask me during our first class. So this is question number 6. You are given a figure of graph here. This is simple harmonic motion graph type of graph or any wave type of graph. It is vibrating with the x-axis is um, showing the time in second and y-axis is showing the displacement in centimeter or x. So the first question asks you to find the value of amplitude, and amplitude is the highest peak or the lowest peak of the wave. So from your graph, this is my sketching of the graph. So from the graph, you can see that the highest peak that this wave can reach is 2 centimeter, and then the lowest peak of this wave can reach is negative 2 centimeters. So the amplitude, or also symbolized as A, is equal to 2 centimeter. You can change your answer into SI unit, whichever you prefer to. Now, question B asks you to find period, which is symbolized as T. Period is the time for one cycle complete its cycle. So in this case, the period is supposed to be from this point to the next point, which it is positioned in one full cycle. So in this graph, the period is from this point towards this point. So the period t in this graph is equal to 4 seconds. Now, question C asks you to find the angular frequency. So angular frequency can be written from or can be derived from this equation 2 pi over t, and we already found our period from the previous part of these questions. So just substitute the value of period here. So it is supposed to be 2 pi over 4 seconds. You will get pi over 2 radian per second due to this one. Now question D asks you to find the maximum speed of this wave. So to find this, you have to start with the total energy equation, which is it is stated that total energy is equal to, can be written as a half mv maximum square, which this is the v that you need to find. And since this is an oscillating or simple harmonic motion type of motions, so you can equalize these equations with the value of energy in spring constant, which is equal to half half spring constant a square. A is the amplitude. So by rearrange this one, I will finally get the value of V maximum, which equal to amplitude times with the square root of K over M. But then the problem is I don't have the spring constant and I don't have the mass. So I have to rearrange once again these equations so it is compatible with the information that I have. And I know that the value of angular frequency is also equal to K over M. I do think this is explained to you in your lecture, but if not, then you will see these equations or the derivations of this equation in your chapter 2, wave and sound wave. So by substituting this omega over here, you will finally get an equation where the information is where you have the informations of the equation, which is amplitude times with the omega. So the amplitude is 2 centimeter, and then the omega is pi over 2 radian per second. Eventually you will get the value of v maximum, or the velocities, or the maximum speed, is equal to pi centimeter per second. So this is D. Now we move to the next questions, where you need to find the maximum accelerations. So to find the maximum acceleration, you need to start from these equations. So you want to find these equations, you want to find this value a maximum, then you have to equal it with the f maximum over here. Rearrange this one, you will get a new equation, which is m maximum is equal to f maximum divided by the mass. But then once again, I don't have the mass, so I have to rederive this equation so that there is no mass in these equations. Then these equations can be the f maximum, or the value of force in a wave, also can be written as the multiplications of the k, your wave number, times with the amplitude, divided by the m. And then this will lead you to get these equations, which is omega squared times with the amplitude. So by substituting the value of omega equal to pi over 2 radian per second square with the 2 centimeter, eventually you will get the value of A maximum is equal to 4.93 centimeter. Now we come to the last questions of these questions. You were asked to find the equations for its position, which is x, in terms of sine function. Now, if we recall it again, this type of graph was a sine wave graph. Please refer your mathematics knowledge, because the wave is start from 0, 0 positions. So this is sine wave graph. Then the general equations of positions or displacement for this question, it's supposed to be x a sine omega t. So this is the general equations of the wave in these questions. So you have your value of A, which is 2 centimeter, then just substitute it. Sine omega is pi over 2, then t is constant with that value. Then this is your answer for last questions.